Okay, so we are we are in phase of calculating the radius of geostationary satellite. Radius of geostationary satellite. Okay, now what is geostationary satellite is I have is I have I have Earth. I have Earth, and there is a satellite that is rotating around the Earth. Okay, Earth rotates on its own axis, and it takes 24 hours to rotate on its own axis. Okay, so consider that Earth is rotating one full rotation, it takes 24 hours. In that is the case, this satellite where it is in 24 hours, it should rotate and it should come to the same location. The way Earth is rotating, it should rotate exactly like that. Okay, and this is called geostationary satellite. Now consider I am designing geostationary satellite. I am a scientist and I am thinking how to place geostationary satellite in the space so that it would rotate around the Earth. If Earth is at the center, if Earth is at the center, then the satellite would rotate around the Earth. Okay, so Earth is at the center and Earth is rotating on its own axis. So that way this will rotate exactly like that. Okay, what is the use of this? Because the the antenna, the radar, the antenna that is pointing toward the satellite to receive information from the satellite. Now, satellite, since it is far away from the Earth, it is able to see ocean, cloud, and everything. Now, it has information, but the antenna I am through which I am watching the information from the satellite, antenna will keep on moving if satellite is not stationary with respect to the Earth. In that sense, if it is geostationary, then antenna is fixed in one direction only. It will be exactly in that direction for whole life. So, how to design, how to place a geostationary satellite at a distance r from the center of the Earth, at distance r from the center of the Earth, or at height h from the Earth's surface, how far it will be, so that it will look stationary as per the reference to the Earth in comparison to the Earth. Okay, if that is the scenario, then how we can design this geostationary satellite? Anyway, there is one fundamental that consider that consider there is a circular road. There is a circular road, and there is nothing in between. In between there are grasses, and there is a big circular road, full circular. Okay. Now I am on a motorbike and I am driving motorbike along the circle. Along the circle at the center there is nothing. Okay, when I drive a bike, I'm designing a geostationary satellite. Now when I'm driving the bike along this circle, when I'm driving the bike along the circle, where at the center there are grasses, there is no energy source in center. Only bike is rotating. Consider like that. If bike is rotating like this, then bike is doing work. Bike fuel is burning, right? If fuel is burning, means energy is involved there. That much energy fuel is losing or it is generating. What is that energy? Consider bike is moving with the velocity v. V means this much kilometer per hour. This is a distance, right? If I open it, if a bike makes a full rotation, if bike makes a full rotation, then how much bike has traveled? That is 2 pi r. If I open it, this much the distance bike has traveled. Okay, so the distance is 2 pi into the radius, that is the perimeter, that much bike traveled. Consider bike velocity is v. V means this much kilometer per hour, or this much meter, this is this much meter per hour. So I believe the measurement is kilogram, meter, and second. That is the actual measurement. Let's calculate in kilometer per hour right now. This much kilometer per hour is the velocity. How much is the energy that at any moment bike 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 is kind of bike has? How much energy it has? We go with energy. That's why This discussion is different from any whatever you see in the book. In the book, it goes with the acceleration, it goes with the velocity, it goes with many other fundamentals. But we are going through energy calculation. That is different. Probably no one would have done through energy calculation. Very simple. Now, bike has energy of mv square. If bike is moving with velocity v, and it has mass m, then as per Einstein theorem mc square, the bike has at that moment bike has velocity of mv square. At any moment, bike has velocity of energy of mv square. That much energy it is carrying. Okay. Now, as per the physics fundamental, the any what physics fundamental? Anyone can try driving the bike along the circle. He will feel there is a force that is taking him out of the center of the circle. That is called centrifugal force. Centrifugal force. So, if someone is driving bike in a circle, he feels that someone is pushing him outside the center of the circle, away from the circle. What is that energy that it is pushing it? That is the same energy what bike is generating. That is mv square. So energy, the centrifugal energy at the point where bike is moving with velocity v is mv square. Okay. Now consider that bike is moving. Now there is a earth in there is a earth at the center. Bike now bike is rotating around the earth. I mean now replace bike by a satellite. Now there is a satellite that is rotating around the earth, and there is earth at the center. Okay, the satellite is rotating at a speed of v. Then satellite is has the centrifugal energy. This is centrifugal energy that is away from the center. So satellite is feeling that someone is taking him away from the center. That is centrifugal force. At any moment, the energy, centrifugal energy, this is the term we are bringing in, centrifugal energy. That satellite is gets thinking it has is mv square. mv square. Now, if it is mv square, then Earth is pulling the satellite around towards it because of Earth energy, Earth gravitational pull, Earth gravitational force. Force into displacement is energy. That much energy Earth is trying to impart on the satellite. Satellite has energy because of mv square. Satellite is moving with a speed. It has energy mv square. mv square is a centrifugal energy that is toward, away from the center of the center, that is the earth. And earth is pulling it towards its center with energy. What is the energy? If gravitational acceleration g is g, then force is g into m. Then energy is force into displacement g into m into radius. Radius is from the earth center to this point. That is the radius. So earth is pulling it with the energy that is mass into gravity into r. Mass into gravity into r. Okay, why this is one scenario? What is another scenario? Another scenario of the calculation is earth gravitational force is radial to the circular direction. If the satellite is moving in a circular direction, satellite is moving in a circular direction, then earth gravitational pull is exactly towards the earth at every moment. If this is the earth exactly at the center, then a gravitational pull around from any direction, it is exactly like a toward the center. If that is true, then if I take the direction of the satellite at any moment, this radius is perpendicular to the earth. Any moment it is perpendicular to the earth. If that is the case, then energy, consider the satellite is moving. Satellite, I placed an iron ring around the earth. This is earth, and I place an iron ring around the earth. Now satellite is moving on the iron ring. It is moving at very less speed, even though earth cannot attract it because satellite is inside one ring. Satellite is moving inside one ring. So if earth pulls it, ring will stop it, and then satellite is nicely rotating around the ring, around the earth. Okay, if that is the case, then how much is the energy earth is imparting on the satellite? Zero, because earth gravitational pull is along the radius, and it is The satellite is rotating along the arc of the circle that is perpendicular at each any point. Force into displacement, force vector into displacement dot displacement vector is energy. Earth is not imparting any energy. The satellite is moving completely because of the fuel only. Earth is neither assisting the satellite to move nor it is resisting the satellite to move. Neither it is supporting nor it is opposing when satellite is moving in circular direction. Very nice. Now remove this remove this ring, and now if I remove this ring, then satellite is moving in a circular fashion around the earth. Now, if it is moving in a circular fashion around the Earth, Earth has no energy disturbance on the satellite. But problem is that satellite would get attracted toward the Earth. The moment it starts getting attracted toward the Earth, Earth will start doing work on the satellite, and slowly it will fall. The work done by the Earth on the satellite must be zero. Okay, if it is non-zero, then earth has a hindrance, earth has a disturbance on the satellite. So satellite is rotating on the, now if how far it should rotate around the earth, so that the satellites, the angular speed of the satellite, angular speed means how much degree there is a change. Okay, there is a term called angular speed. Consider this is the satellite path and this is the radius. If satellite has made from here to here in 1 hour, then angular speed is pi by 2 per hour. This is angle in radian is pi by 2. If satellite makes full rotation in 24 hours, then angular speed is 2 pi per 24 hours. That is the angular speed, 2 pi per 24 hours. That is angular speed. One is called linear speed, that is V, we are saying mv square is the energy. So what is V in terms of angular speed? What is the displacement it is making with respect to angle? If I talk about angle, then what is the displacement it is making as far as angle is concerned? Then this displacement arc is nothing but angle, the angle it is traveling into arc. Okay, arc, the if someone is traveling pi, if someone is traveling pi by 2, if someone is traveling pi by 2 angle, what is the length of this arc? That is pi by 2 into r, angle into r. Okay, so the relationship between v and the linear velocity and angular velocity is v equal to omega. Omega is angular speed, that is in angle, then omega into r. V equal to omega into r. Okay, if that is the case, then net energy is mv square, that is m omega square r square. That is the energy. Now, if a satellite, if a geostationary satellite is rotating around the earth in same way the earth is rotating, the earth angular speed is 2 pi angle per 24 hours. Now the centrifugal force this satellite is feeling when it is rotating, not because of earth. When anything rotates in a circle, it feels one energy that is pushing him from the center. That energy is same as whatever energy it is imparting. If it is moving with energy v, velocity v, then centrifugal force is same as whatever energy this is carrying. That is mc square or mv square. Then mass into velocity square, that is linear velocity. If I talk in angular velocity, then mass into omega square r square. Omega is angular velocity. Angular velocity into r. Angle into r is the peripheral, is the curve length. So m omega square r square is the centrifugal energy. This energy, if the outward energy is same as what it was with what energy earth is pulling, then it will not get attracted to the earth. Neither it will go in the space. It should be exactly same. What is the energy through which earth is trying to impart on this entity, irrespective of the rotation? Even it is still how much energy earth is pushing on this guy. That is the gravitational pull into its mass into radius. That is the distance. mgr. m mass of this. What is the gravitational pull G? That is capital G, that is some gravitational constant, capital G into capital G into mass of the earth, capital G into mass of the earth divided by r square. Actually, it is r vector by r to the power 3. But since it is along the r vector, so it does not have any meaning. So the centrifugal force is m omega square r square. And this is capital G capital M. That is that what is this is mgr. M omega square r square equal to mgr. Gone here one, and r and here r square. R gone here one. And now it becomes omega square into r. Omega r square into r equal to g. G is the gravitational pull acceleration. Then small g is equal to capital G, that is one constant, into mass of the earth divided by the distance square. More we go, gravitational pull is less, acceleration is less. So capital G and mass of the earth, that we will see, and by r square. Here we have omega square into r. Now it becomes r to the power 3 equal to capital G into mass of the earth by omega square. Then radius is from the center of the earth, that is r. Then radius equal to capital G into mass of the earth divided by omega square to the power 1 by 3. Okay, so that we will see how much it is. Okay, I personally calculated it, where it went. Okay, the gravitational acceleration of earth is capital G into mass of the earth divided by the distance from the center of the earth square, gm by r square. If we are trying to calculate in the r direction only, otherwise it is minus gm r vector by r to the power 3. Anyway, now it is the capital G is 6.67 into 10 to the power minus 11, and mass of the earth is 5.98 into 10 to the power 24 kilogram. That is the mass of the earth. Okay, and what is the angular speed omega we are talking about? That is 2 pi by 24 hours. That is the 2 pi radian full circular rotation it is making in 24 hours. Now it resolves into g into m by omega square to the power 1 by 3. That is the radius. G is 6.67 into 10 to the power minus 11. M is 5.98 into 10 to the power 24. And omega is 2 pi by 24 hours. 2 pi square become 4 pi square, and 24 hour, that is the denominator, it will go up 1. So 24 hour, now 24 hour square. 24-hour square, I have to convert into second. So 24 hour into 3600 in 1 hour, that must second square. So net it will come as 6.67 into 10 to the power minus 11 into 5.98 into 10 to the power 24 into 24 into 24 into 3600 into 3600 divided by 2 pi into 2 pi whole to the power 1 by 3. That is the kilometer distance. I calculated it, and it comes at 41,000 kilometers. 41,000 kilometers, where all the satellites are at distance of 100 kilometer to 400 kilometer. Geostationary satellite has to be at 41,000 kilometer from the center of the earth. Earth is around 6,300 kilometers around. If I decrease it, it will come more or less 34,000 kilometers. Moon is at 300,000 kilometers. 34,000 kilometers, I have to take one satellite from the surface of the earth, and there if I rotate it around the sun, around the earth in the same speed the earth is rotating, then earth will not be able to pull it. What speed? That is the speed. Speed is that the angular speed is 2 pi in 24 hours. Angular speed into radius, angular speed into radius is the actual velocity. So angular speed is 2 pi by 24 hour. 24 is 24 into 3600 second. 2 pi by 24 into 3600 second into radius, that is coming into the radius, that is coming at 41,000. If someone calculate it, that is the kilometer per second is the speed of the satellite. I did not calculate it, but someone can try. 2 pi by 2 pi 2 pi into 41,000 kilometer by 24 into 3,600. If someone does it, that, or if some, I believe, if I don't calculate in second, then that will be per hour, I believe so. Then 2 pi into 41,000 by 24, how much it will come? Okay, 41,000 into 82 into 3.1, that is 5. Around 250 by 24. Around, I believe it will come as 10,000. 10,000 kilometer per hour is the geostationary satellite speed is 10,000 kilometer per hour. Can someone believe it? That if this is the Earth at a radius from center, from the Earth's surface around 34,000 kilometers. From the surface 34,000 kilometers, one satellite is rotating around the Earth at the speed of 10,000 kilometers per hour. Can someone believe? Then it will be stationary in the sense whatever centrifugal energy that it is seeing outward and whatever the earth energy that is he is seeing toward the center are nullifying each other. But then he has to move at 34,000 kilometers away from the earth's surface and 10,000 kilometers per hour speed, then it will be geostationary. They are satellite. That's why television and those things people were watching because of the geostationary satellite only. Means from Earth, people were throwing the television serial to the geostationary satellite, and from there it was catching and it was throwing to the Earth back. All the antenna on the Earth, they were fixed watching. So those antenna actually, I believe nowadays the this antenna is coming, right? All are in a same direction only. They are never changing. All are pointing to the geostationary satellite only. Okay, from Earth they are throwing, uploading. I believe it is called uploading the data to the geostationary satellite. From there, it is these dishes that is people see on the every house on the roof. They are receiving the signal from geostationary satellite that is at 34,000 kilometers, rotating at 10,000 kilometers per hour. But the person who has kept the antenna, it is completely still. To make you enjoy, someone is working this much. Can you see this? Just think that how much God is working for you. Makes sense, right?